Everybody uses servers, but almost nobody knows how they actually work. Today we're going to be changing that by turning this pile of electronics into this Minecraft server. Now, I'll be honest, the premise of this video is that I go back to my family's house in 5 days, and I wanted to build a server in that time and finish the video. So this is actually day 5 of that little mini challenge. So if things appear rushed, cobbled together, they were. I did order the parts in advance. I just had them sitting on my desk and decided to jump right into it when winter break started. The idea was I wanted something like a Raspberry Pi, but more powerful. I opted for this thing called the Radxa board. It's like this pretty cool Raspberry Pi clone. I wouldn't even call it a clone. It includes a lot more features than Raspberry Pi does, but it's got RAM, 16 gigabytes of it. It's got HDMI ports. It's got M.2 slots. It's got everything I needed. So I bought one, the Rock 5B, and I got 4 SSDs with it. And the idea was I can hook these SSDs up to the Radxa and have my own server. And one issue though was power delivery. The SSDs take 5 volts, right? But so does the Radxa. But I needed like a solution to power both that didn't involve me getting some beefy PSU or otherwise annoying power adapter. I just wanted something that'd fit in my desk, no big bulky stuff attached, right? So I opted for getting a buck converter to power each of the two with a screw terminal breakout. And I was getting my voltage in from a USB-C at 20 volts. The whole flow of it was I'd take 20 volts in from the USB-C, I'd route that to the 5-volt buck converter, and then I'd route the 5-volt buck converter to the screw terminal board, of which then routes to power the SSDs and the Radxa board. And the idea, assuming it all worked, right, I'd take the USB-C cable, plug it in, that's it, powers everything. And once it's all connected together, assuming everything works, the idea was to then stress test it with none other than a Minecraft server. Because obviously, if it can run Minecraft, it's pretty much like already NASA grade or something, so should be fine. So I started the project by soldering the buck converter and the USB-C negotiation chip for supplying 20 volts to the buck converter. I was having issues with solder adhesion, so I needed to buy some flux and new tips from Amazon. Once the pin headers were added to the board and the USB-C connector, I tested both to make sure that they worked. Things looked good, so I moved on to actually 3D printing a case for the USB-C to be held in. Because without a case to hold it, it was kind of sketchy having to grab the sides of the board and like wiggle in a cable and hope it just didn't snap off the solder joints. So it took me a bit, but I modeled something in FreeCAD that I was pretty happy with. These are all the different attempts I had in modeling the holder for the USB-C, but I'm fairly happy with how the final version turned out. Right here, looks like 5 volts, cool. After I knew the buck converter was successfully supplying 5 volts, I decided to move on to wiring everything together. And this included stripping the wires for each of the SSD connectors, setting up wires for the screw terminal connections, and then plugging everything into the screw terminal connections itself. I had a bit of an issue looking for a screwdriver. I'd actually seemingly lost all of my tiny screwdrivers, but I ended up improvising with a tiny squished syringe tip. It managed to fit the screw terminals just right, and I was able to screw everything into place using it in some pliers. So after wiring everything up, I decided to do a continuity check on the board with a multimeter. And I'm glad I did, because I realized there was a short on the board and I had no idea why. So the pins, if I push them all the way in, they clip the heatsink, which is super sketchy. It was from the heatsink. So the heatsink on the Radxa board actually was touching every single one of the pins on the screw terminal breakout and causing it to short. If I had powered that without doing a continuity check, the entire board would have been effectively fried, but that didn't happen. So I thought for a bit and decided to get some Kapton tape and just kind of put a little strip over the pins so that they wouldn't short. And this worked. I think. It hasn't shorted yet. You can kind of see for yourself and be the judge of how sketchy that is. Yeah, but so long as the pins don't pierce the Kapton tape and it doesn't slide off, there should be no electrical issues. So after validating power distribution, I decided to move on to setting up the operating system for the board so that I could actually test all the hardware that I was powering and connecting to it. I used Rufus to flash Debian with KDE onto this eMMC card using this eMMC to micro SD card reader. After Rufus finished, I was ready to test. So I plugged everything together to validate that it worked, and let's fucking go! It did. So I was now at a point where I could turn the server into something that TSA might be more comfortable with. But this was a fairly visual process, so what better way to show you than with a montage? After everything was modeled and printed, it was time for assembly. I would have used heat insert screw threads, but I was tight on time, so I opted for just manually drilling the screws into the prints instead. After which, the server was finally complete. And as promised, what better way to test it than to test it with Minecraft? Welcome to my computer. So we're gonna be setting up the Minecraft game here, and first we've got to update everything. So we're gonna hop into the terminal, run a bunch of commands, and download this thing called Prism Launcher. That's what we'll use to install Minecraft. Took a little bit of troubleshooting, but after deciding to just use version 1.12, we were in. And wow, let me just say, look at those decent graphics. Look at that moderately unnoticeable lag. And don't forget to mention that I'm screen recording this off of a capture card and forgot to set up audio pass-through. It's great. The real test to see if Minecraft really works or not is to, well, mine and craft. Assuming we can both mine and craft, I consider this test complete. Oh, looks like I can mine this tree. That's pretty huge. And looks like I can craft wood. Even more huge. We've proven we can mine. We've proven we can craft. This is truly the NASA server of all time. I need to get back to editing this video before the day ends. I think I'll have time. If you're watching this video, I did. Amazon affiliate links are in the description for everything I bought off of Amazon for this project, as well as the files I uploaded, so you can print one of these too.